Have you ever wondered why a small machine usually uses a PLC, but an entire refinery almost always uses a DCS? Both systems control industrial processes. Both use inputs and outputs. Both can automate equipment. So why do large industries spend millions of dollars on DCS systems instead of simply installing a bigger PLC? By the end of this video, the difference will be completely clear. PLC section. Let's begin with the PLC. PLC stands for Programmable Logic Controller. Think of it as the brain of a machine. Everything starts with the input devices. A push button. A proximity sensor. A pressure switch. Or a temperature sensor. All of these send electrical signals into the PLC. Inside the PLC, the CPU reads every input. Then, it executes the program stored in memory. The CPU makes logical decisions in only a few milliseconds. Finally, it sends commands to the output modules. Those outputs may start a motor, energize a contactor, open a solenoid valve, turn on a heater, or activate an alarm. The entire process happens continuously. Read the inputs. Execute the program. Update the outputs. Then repeat again. Thousands of times every second. This repeating process is called the PLC scan cycle. If you understand the scan cycle, you understand the heart of every PLC. Why PLC is popular. So why is PLC so popular? Because it is simple, fast, highly reliable, and relatively inexpensive. If you need to automate a conveyor, a packaging machine, a water pump, or a production line, a PLC is usually the best choice. One controller. One program. One machine. Simple. Transition to DCS. Now imagine something much larger. Not one machine, but an entire power plant. Or a refinery. Or a chemical factory. Thousands of sensors. Thousands of valves. Hundreds of motors. Would one PLC be enough? Not really. This is where DCS becomes the better solution. DCS section. DCS stands for Distributed Control System. The keyword here is distributed. Instead of using one central controller, the control is divided among many controllers. Each controller manages a specific part of the process. One controller may supervise the boilers. Another controls the cooling system. Another controls pumps. Another manages compressors. All of these controllers communicate together through a high-speed industrial network. From the operator's point of view, everything still looks like one complete system. But internally, the work is shared among many controllers. This architecture makes the entire plant more reliable. Why distribution matters. Imagine one controller suddenly fails. In a traditional centralized system, the entire process may stop. But in a DCS, only one small section is affected. The remaining controllers continue operating normally. This is one of the biggest advantages of DCS. Higher availability. Higher reliability. Less production downtime. For industries where every minute of shutdown costs thousands of dollars, this advantage is extremely valuable. Engineering stations. Now look at the top of the DCS diagram. You can see several computers. Each one has a different job. The engineering station is where engineers create and modify the control logic. The operator station allows operators to monitor the entire process in real time. They can see temperatures, pressures, flows, motor status, alarms, and trends, all from one screen. The historian server records process data continuously. This information can later be analyzed to improve efficiency, reduce energy consumption, or troubleshoot problems. PLC versus DCS comparison. Now let's compare both systems directly. A PLC is usually centralized. A DCS is distributed. A PLC is ideal for individual machines. A DCS is designed for complete industrial processes. PLC systems are easier to install. DCS systems are easier to expand. PLCs usually cost less. DCS systems cost more, but provide much greater redundancy, higher availability, and better plant-wide monitoring. Neither system is universally better. The correct choice depends entirely on the application. Real industrial example. Imagine a bottling machine producing soft drinks. It has sensors, motors, and pneumatic cylinders. One PLC can easily control everything. Now imagine an oil refinery. Thousands of pressure transmitters, flow transmitters, temperature transmitters, control valves, compressors, boilers, heat exchangers, and safety systems. No single PLC should manage all of that. A DCS is designed exactly for this level of complexity. So remember these three ideas. PLC controls machines. DCS controls entire processes. And both systems use the same basic principle. Read the inputs. Process the logic. Update the outputs. The difference is not in the purpose. The difference is in the scale. Once you understand that, choosing between PLC and DCS becomes much easier. In the next lesson, we'll explore exactly how PLC and DCS communicate with field instruments, and why communication protocols are one of the most important parts of modern industrial automation.